Welcome back, grade 11s. This is part 2 of our lesson on completing the square. So to start ourselves out, we actually did not complete the square. We took something that was in vertex form, we expanded it, we collected like terms and simplified to get y equals 2x squared plus 12x plus 17, which is standard form when it's all multiplied out. So our second question that we want to try is we want to see if we can complete the square on y equals 2x squared plus 12x plus 17. And you might notice that this equation here is the answer that we got when we multiplied out y equals 2 times x plus 3 squared minus 1, right? So I planned that so that we can try to see if we can follow some steps to work backwards to figure out how to take standard form and turn it into vertex form. So some of the steps are fairly straightforward. Some of the steps are a little bit complicated. So if I take a look at what we did and try to do it backwards, I see that we had an expression, and then we had two terms that we collected together to make that last term of 17, right? If we work backwards here, if I ignored that last term, we have common factored out a 2. And then the x squared plus 6x plus 9 we got from here. And this, if I move backwards, is actually just factoring, right? So if I can get it to this step, I can work backwards on that bracket and factor it. The tricky part is trying to get from here to that step. So there are a lot of numbers that will add or subtract to 17, and there is no easy way for us to figure out that it specifically needed to be 18 and 1. So when we're trying to do this in reverse, I don't actually know how to get from this step to this step, but we can go from this step to this step, but it takes more than one step to get there. So it is a very odd process that we're going to follow. You're just going to have to trust me. If you took academic last year, you would have done this before. If you took applied last year, this is all brand new for you. So we're going to do the question, then we're going to write in some steps about what we did, and then we'll try some practice. And the more we practice, the better it gets. So it says complete the square, y equals 2x squared plus 12x plus 17. So I want to take this and turn it back into this. So we're trying to get from here to here. That's our first start. Okay, so when I look at this, I notice that I have a bracket with a number out front, right? There's a number on its own outside, and then there are 3 terms inside of the bracket. So when I'm trying to work backwards, the very first thing we're going to do is try to get that number that's outside of the bracket. So we do that by taking all the terms that have an x and grouping them together. So I'm going to write, we have y equals 2x squared plus 12x plus 17. And we are going to group just the first 2 terms together. We're going to ignore that 17 for right now, right? It'll get its turn in a bit, but we're just going to focus on the terms that have an x. And you'll notice when we looked at this, that there was a number out front and there wasn't a number in front of the x squared. So what we're going to try to do is find a way to factor out the 2. So I'm going to take just those 2 terms and we are going to factor out a 2. So I'm going to say it's 2 times. Now, I do notice that they divide by 2 and x, but I do not want to take the x. You have to resist the temptation to do that. So I'm going to factor out the 2. 2x squared divided by 2. Well, 2 divided by 2 is 1, and then x squared. I'm not going to write the 1. I'm just going to write the x squared. And then I do 12 divided by 2. 12 divided by 2 is 6, and it still has an x, so it is 6x. And then I still have that 17 that's hanging around at the end, and it's going to have to wait a while to get its turn. Okay, so I have the 2 factored out. We're going to go back up and look. So I have 2, I have x squared, I have 6x. I have all those things that I need, except I don't have the 9. and this number is not a 1, it's a 17. So I've got the number out front, right? I've got the first two terms. I'm just missing this term, and this term doesn't quite match right now. So how are we going to get that extra term inside the bracket? Well, we're going to try to see if we can find something that will make this factor, because ideally that's what we're doing here. We take this and then we factor it, and it factors to actually be a perfect square. That's why this is called completing the square. We're trying to make something here a perfect square. So I need to see if we can find a third term that would complete this bracket and make it factor. So I'm going to think about what we know about factoring, right? I know that when we factor, we normally take the first term and the last term, we multiply those together, and then we look for two things that multiply to whatever that top is and add to the bottom. So it has to add to 6x, right? So I don't really know what the top multiplies to because I don't currently have that number, right? We're missing this number here. But I do know something about this. I know that it is supposed to be a perfect square. So if something is a perfect square, that means that the two numbers that I'm picking here that add to 6x and multiply to whatever the top is need to be the same number. So I need two numbers that are exactly the same that add to 6. So you might know, if you look at the previous example, it's 3 and 3. So 3x plus 3x makes 6x, and they're exactly the same number, right? You could also take 6 and divide it by 2, right? That would split it into two numbers that are the same. Then from here, I'm going to multiply, because that's how we get the top. 3x times 3x. 3 times 3 is 9x squared. So I took the 6x, I looked for two numbers that were exactly the same that added to 6x, and then I multiplied them to get that top part. So we're doing things in a different order from what we normally would do when we're factoring. Okay, I know, it's all a little weird. So what I want to do, x squared times something equals 9x squared. Well, x squared times 9 would equal 9x squared. So I'm going to add 9 into the bracket, which you'll notice is what was here. So that's good. However, if I just randomly add a 9 into my equation, it's not the same equation anymore, right? It's a completely different parabola. It would look different if you graphed it, and they wouldn't be equal. So I can't just randomly add a 9. So what I do, because I really, really want that 9, is I cancel it back out by subtracting 9. And I know that seems weird, right? But 9 minus 9 is 0, so I haven't really done anything to change the equation. But I did find a way to get the plus 9, which I wanted. And some of you are probably thinking, well, but Ms. Pick, if I add 9 and subtract 9, I'm just going to end up back at x squared plus 6x. But the trick is we don't add the 9 and the minus 9. You'll notice up here we have x squared plus 6x plus 9. And then this number out here is not the 17 that we currently have. And the minus 9 plays a big part in that. So what I would like, ideally, is I would like to have 2 times x squared plus 6x plus 9. That's what I want in my bracket. I don't want the minus 9 in the bracket. So why is the bracket there? Well, the bracket is there to show that we are multiplying by 2. So if I were to multiply that negative 9 by 2, it wouldn't need to be in the bracket anymore. So I'm going to take this 2 and I'm going to multiply by negative 9 so that it doesn't need to be in the bracket anymore. And then we still have our little friend 17 that's been very patiently waiting at the end here for its turn. Okay, that step was strange. So I kept the plus 9 in the bracket, and to get the minus 9 out of the bracket, the reason the bracket is there is because we are multiplying by 2. So if I multiply it by 2, it doesn't need to be in the bracket anymore. So we're going to leave the beginning parts. We have y equals 2 times x squared plus 6x plus 9. And then 2 times negative 9 is negative 18. You can use your calculator to help you if you want. And then we still have a plus 17. Negative 18 plus 17 is negative 1. So I have 2 times x squared plus 6x plus 9, and then minus 1. Okay, so all of that work, all of these steps, we had 1, 2, 3, 4, 5 of them, was just so we could go from here to here because we didn't know what this number was. So when we multiplied it out, it took 2 steps. And when we went backwards, it took 5 steps, right? So it is a lot of steps in that process. And we're not even done yet because we still have one more thing that we need to do, right? If I look at this example, oops, right, this part here was x plus 3 squared. We did that work over here. When we multiplied it out, that's what it looked like. If we're going backwards, we would go backwards to make it a multiplication question by factoring. So the very last thing we need to do is factor x squared plus 6x plus 9. So I'm going to take x squared plus 6x plus 9. I'm going to do it off to the side just like we did when we were expanding because otherwise it gets a little messy over here. So I'm going to write x squared plus 6x plus 9. Now, when we factor, right, we look at the first term and the last term. We want to figure out what multiplies to 9x squared and adds to 6x. The good news, we've already figured it out, right? I already know what multiplies to 9x squared and adds to 3x. It's 3x and 3x. So I don't have to think about it. I don't have to rethink it out or try to do any work. I already know the two numbers. So this is x squared plus 3x plus 3x plus 9, right? We're just replacing the 6x with 3x and 3x. And then we are going to group the first two terms and the last two terms together. The first two terms both divide by 1 and an x. I think I'm just going to write x. If you want to put the 1, that's okay. X squared divided by x, that's just x. And then 3x divided by x is 3. The second pair, that middle sign always comes from the middle, right? And then they both divide by 3. If you're not sure, you can look at a multiplication grid, right? You should hopefully still have one from back when we did this in unit number 1. So 3 divided by 3 is 1x. I'm just going to write x. And 9 divided by 3 is 3. So I know that I've done this right because these two brackets are identical. That means when I multiplied out the binomial, that second bracket was x plus 3. And then my first bracket comes from these terms, so this is x, and this is plus 3. So I have x plus 3 times x plus 3, which is x plus 3 squared. So I'm going to take my x squared plus 6x plus 9 and replace it with x plus 3 squared. So I have 2 times x plus 3 squared minus 1. So we managed to take a quadratic that was in standard form and turn it into vertex form, but it took a lot of steps to get there. Now there are some shortcuts that we will talk about in a couple of days, but for right now we're going to try to follow this process. So I'm going to stop this video here. We will come back to this question and we will write in some steps of what we did, so things that you can follow, and then we'll try some more practice questions. I'll see you in the next video.